Hi everyone, welcome to watch this demo video. The 3D display can provide binocular depth perception and an immersive 3D experience, which have been widely developed in recent years. Among the variety of 3D display technology, a novel technique called dual-layer 3D factory display was proposed in 2010. It provides a high-resolution full parallel 3D experience and could be a possible solution to solve the convergence accommodation conflict in AR and VR applications. However, the light field factorization algorithm used in this technique requires a lot of DRAM bandwidth and high computational complexity, which is not efficient to implement in CPU and GPU platforms. To solve this problem, we designed a light field factorization processor to accelerate the computation progress and facilitate the real-time light 3D factory display. Our light field factorization processor includes three key features. First, we use a half block-based processing flow to avoid iterative DRAM access. Second, we propose a sparse light field subsampling method to reduce the DRAM bandwidth and required operations. Third, we apply a hybrid precision optimization in a fixed-point light field factorization engine to reduce the area and power consumption. Here shows the demonstration platform for the dual-layer 3D factory display. We use a laptop to transmit the target light field and UR command to the FPGA. The light field data will be temporarily stored in the DRAM and interact with our light field processor through the FNC connectors. As the processor finishes, we use a laptop to capture the factory output and display on the dual-layer LCD panels. Here shows the demonstration. The selected light field content is sent to the FPGA. We use the FPGA to provide the processor with the DRAM and the I/O interface. We also use two power supplies to provide the chip's core and I/O power. The factory result is captured back to the laptop and then driven to the factory display from the laptop GPU. The dual-layer factory display prototype demonstrates the factory light field. The display consists of two regular LCD panels. Stacking together, we can perceive the 3D contents. Here is how the factory display works. The viewer can perceive the product of luminance from both LCD panels. We now show the example contents on each panel. The content seems trippy in a low frame rate on each panel. However, when we show both panels and increase the display frame rate, the trippy patterns are fused and collectively form the light field. It is called temporal modulation. The factory display can deliver full parallel 3D, which means you can perceive from different viewing angles, including horizontal and vertical. Following the camera movement, we can observe the object from different perspectives. Here shows the real-time light field factorization. Each light field is processed separately in rank 1 factorization. The demonstration is operated in 50 MHz with the FPGA board, and the real-time power consumption is shown on the power supply. This light field factorization processor supports 7x7 view, rank 1, 2, and 4 factorization. The maximum throughput reaches up to HD 31 frames per second with consuming 2 to 900 mW. The normalized energy of this work is reduced by a factor of 10,000 compared to the GPU platform, and the computational throughput is 6 to 24 times faster than the previous state-of-the-art. Thank you for watching this demo.